So I wanted to show you a couple of examples of when we want to rotate a region about something other than the X or Y axis. So our idea of R and little r are both going to be still that distance from the axis of rotation. So we'll just have to kind of keep track of how far those r's are from the line we're going to spin around. Okay, so the first example here, we're going to find the volume generated when the region enclosed by, so I have y equals x equals 2, x equals 0. So there's our region, and we're going to rotate about the line y equals -2. So the first thing we want, of course, is a graph so that we have an idea of where we are. So y equals y equals e to the x. So that looks like this. X equals 2. So that looks like this. So here's my x equals 2, x equals 0 is the y-axis. So we're talking about this region right here. And what we're spinning around is the line y equals -2. So that is a horizontal line down here at -2. Okay, so I'm going to draw my representative rectangle. So we're going to use the washer method. So we're perpendicular to the axis we're rotating around, even, right? This is still an axis that I'm rotating around. It just happens to be the line y equals -2. All right, so I can already tell that I have dx's. Okay, so I could start, right, just this, and I know that I'm doing dx's because, again, that's my narrow width. And so then I know my limits of integration. X goes between 0 and 2, right? So already I've got that much. But now let's think about those washers. So I need my big R. How far is it from this top down to the bottom? What is that length, right? So it's the difference in those two y values, right? It's the y value here from my y equals e to the x and my y value down here where it's -2. But notice I have dx. So when I talk about the y value here, I want to use the x version of that. Right? So y is the same thing as e to the x. Since I'm integrating with respect to x, I'm going to use e to the x. Okay, so then it's e to the x from here to here, but then I also have an additional, right, distance of 2 down to here. So that first, so my capital R, and I guess just to remember for washers, pi big R squared minus little r squared, and then dx or dy depending on which way you're going. So my big R is going to be that e to the x, and then it's minus, so the distance between top minus the bottom. So then it's minus the -2 squared. So that'll end up being plus the 2. So there's my big R squared. And then my little r squared, right, is that cut out part in the middle, and that's just between y equals 0 and y equals -2. So that's just a space of 2. So that's just going to be 2 squared. Okay, so I'm going to do some, and then remember the pi out front, absolutely. So I'm going to do some algebra in here, and let's see where we go. So I've got, so e to the x plus 2 squared minus 4. I'm just kind of tidying up that integrand. So e to the 2x plus 4, e to the x plus 4 minus 4. So my integrand all tidied up, e to the 2x plus 4, e to the x. So that's what I want to integrate, and I'm just getting it copied down here. Oh, e to the x, and then we're dx. So that first term, right, e to the 2x, I'm going to have to do a little u sub on my way through. So let's break that apart. So we'll go pi 0 to 2 e to the 2x dx plus 4 pi 0 to 2 e to the x dx. So in this first one, I'll let u equal 2x. So then du equals 2dx. So let's see, I've got my dx, so I need the 2. So I'm going to stick a 2 there and a 1/2 out in front. So now I have 1/2, well, pi halves, integral of e to the u du. I'm just looking at this first part. Now I'm going to switch my limits of integration. So if these are x's here in red. So if x is 0, then u is also 0. If x is 2, then u is 4. So integrating, I'm just doing this first one now. So that is going to be pi halves times integrating e to the u du is still e to the u between 0 and 4. Did not give myself enough room. Those of you who know me know this is my MO. So pi halves times e to the 4th minus e to the 0. Okay, so there's from the first part. Now I still have to do that second part. Let's go one more color here. Let's go back to blue. So now just integrating the second one, I've got 4 pi, and then integrating e to the x dx is just e to the x between 0 and 2, so that I get 4 pi times e squared minus e to the 0. So altogether, it's the green plus, okay, so what do I have there? I have pi halves e to the 4th minus pi halves, right? E to the 0 is 1. And then plus 4 pi e squared minus 4 pi. So that is the volume when we take e to the x and spin it around the line y equals -2. Okay, second example. So this time we're going to rotate around a vertical axis. So we're going to take the region enclosed by y equals x squared, y equals square root x, about the line x equals -3. So let's get a graph. So y equals x squared, y equals square root x. They intersect over here at 1, 1. And then we're rotating about the line x equals -3. Okay, so draw it, right, perpendicular to the axis you're spinning around. So I know I have dy's, and my dy's go from 0 to 1. So then I need big R. So big R is going to be, right, the 3 plus, right, this x value here. And that's the x that comes from y equals x squared. But, right, but I want, since I'm integrating with respect to y, I want this y equals x squared. I want the y version of that. So I'm not just going to put y because it's not, right, it goes out to x. So I need to solve this equation for x. So y equals x squared, if I solve that for x, I get x equals the square root of y. Okay. So if I solve that equation, right, y equals x squared, if I solve it for x, I get x equals the square root of y. The reason why I want that is because I'm integrating with respect to y. Okay, so looking at that first, at that capital R, so between 0 and 1, my capital R is going to be square root of y minus the -3 squared. Okay, so there's my capital R squared. So one more time, now that we just have that sitting there, it's, right, the distance from the axis we're spinning around to our, right, to the outside. So I have the 3 plus the additional x value here. But for that x value, I want it in terms of y because that's my differential. It's with respect to y. Okay, so now let's see if we can do it for the other one. So little r, for that inner, right, goes again from -3 over to the x value for the square root graph. But again, right, I need the x value, but I need it in terms of y. So for this one, I'm looking at the y equals square root x part. but I need to solve for x in terms of y. So for this one, x equals y squared. So for my little r, so it's right, big R squared minus little r squared. For my little r squared, it's going to be y squared plus 3 squared dy. Okay, so again, let's tidy up that integrand. So I've got, so squaring, by the way, I've just been doing this. I am totally taking advantage of the, right, squaring a binomial algorithm. So square the first, 2 times the product, a times b, square the last. So when I've just been writing them down, that's what I'm doing. So remember that middle term. So here we go. Just tidying up. So square the first, y, 2 times the product, so 6 square root y, square the last, minus, so this is going to be more than one term, so I'm using my parentheses, so squaring this binomial, so I'll get y to the 4th plus 6y squared plus 9. Take my negative sign through. There might be some tidying, so I have y plus 6. I'm going to go ahead and go to fractional exponents, getting myself set up. Plus 9 minus y to the 4th minus 6y squared minus 9. And let's see, I guess I can just get rid of the 9s. Everybody else is their own thing. Okay, so then let's go ahead and find the antiderivative. Y plus 6y to the 1/2 minus y to the 4th minus 6y squared dy. So y squared over 2 plus 6y to the 3/2, right? Add 1, divide by the new, right? The 3 goes on bottom, the 2 pops up top, minus y to the 5th over 5, minus 6y cubed over 3, between 0 and 1. Oh, and the pi, oh my gosh, you guys, pi. So I'm going to get pi times 1/2. So the 1s are nice because, right, 1 to the anything is still 1. So I've got 1/2 plus 4 minus 1/5 minus 2. And let's see what my calculator tells me, because I want to not make a mistake at this point in the game. So that looks like 2.3 pi. So that's the volume, right? If we take this little I shape and spin it around this line, x equals -3.